Hello everyone, I'm Rex Olson and welcome to a Newtek Tuesday tutorial here on Facebook. Today we're going to use our scopes to match cameras. So let's get right into it. We're going to go to our interface and go to the Workspaces tab. I use D for my scopes. Select D and then go to Load Default and select Scopes. And here we have our scope set up. I have the color chosen as blue so I can see the entire waveform in great detail. And if you haven't seen it already, make sure you check out our previous tutorial on the basics of the scopes in TriCaster. So we're going to take a look at this. We're looking at our waveform and vector scope to match these three cameras. I've got camera 1, 2, and 3 in our inputs. And what we have set up here is we have two Sony PTZ cameras and one Canon camcorder. And we're going to try our best to match all three of those cameras. This isn't an uncommon situation. The ideal situation is to have all matching cameras, because that's going to give us our best possibility of getting all three cameras matched together, or all cameras that we're using matched. But it's not uncommon to have different cameras on a shoot. So in this case, we want to show you how we might go about trying to match different types of cameras. So back to our interface, you can see that we've got our three cameras, camera 1, 2, and 3, and currently they don't look at all like one another. And we're going to do our best to fix that. So the first thing we're going to do is we're going to switch all of our cameras to color bars so that we can make sure that the signal itself coming from the camera into our switcher all match together in with our switcher system. Okay, so now we've got color bars from all three cameras. There's camera 1, camera 2, and camera 3. 1, 2, and 3. And we can see a slight difference between them. Obviously, this is the Canon camera's color bars, very different than the Sony. But the signal that is being generated of the color bars themselves should be the same, because it's a standard in the industry amongst camera manufacturers. So we're going to start with our camera 1 input, and we'll select right-click and select our configuration panel, and we're going to take a look at our color levels on our waveform monitor. Our luminance levels on our waveform monitor. The brightness first, make sure that is hitting our base level, and we're going to go for broadcast levels for this particular shoot. In this case, we're going to set our black at 64, and we're going to set our white bar at 940 in our 10-bit range. And then we're going to look at the vector scope, and we see something rather odd. If you look at the vector scope, we've got this kind of irregular pattern. If we look at the color bars coming from our Canon camera, they're a little more standard. Sometimes we see this in various types of cameras. Not exactly sure why, but we're going to work around it, because this is, again, a real-world situation where we sometimes get camera signals coming from who knows where, and it's what we've got to work with. So in this case, we're going to work with this. And since I tend to steer toward flesh tones, we're going to look at the red magenta part of our scale, and we're going to adjust our saturation to make sure that it hits closely in that target. Since it looks like magenta is the closest thing to reality in this case, so I'm going to just go with that one. And here we go. There, I'm good with that. Do the same thing with camera 2, configuration panel, color, look at our levels, brightness, make sure they're right on that line, contrast, again, right on the line, and then double check. These are all very close anyway, but we just want to touch them up and get a good start in the process, because if we don't get this part right, it's going to make the rest of the process difficult. So we need to work our way up from the color bars generated from the camera itself, so that we know that electronically our signals are correct. And finally, saturation here, and going with magenta. So I'm going to be pretty comfortable as I switch between camera 1, 2, and 3 on preview here. I'm pretty comfortable with the levels being pretty well matched. And 1 and 2 look a little off, so I'm going to fix that. I'm going to go to 1, configure, and I'm going to bring my white level down just a touch. Okay, that looks really good. All right, now we're going to go back to our control of our camera, and we're going to switch color bars off. Okay, now with the color bars shut off on all 3 cameras, now we want to get to color balancing. One thing that you want to make sure, though, before you do this is make sure that the gains on all of your cameras are set to the same level. I like to set them as low as possible. And the way I go about that is in the actual lighting that I will be using. If it's in a studio, I look at the image and open the iris to a typical level, somewhere maybe in the high end or in the middle of the iris. F5.6, for instance, is a good starting point. And see where the gain is and adjust it as low as possible to get a full scale on the waveform. So, important point, make sure they're matching on all of your cameras and keep that gain as low as you possibly can to get the nicest, cleanest picture quality. Okay, let's take a look at the color balancing now. We start our color balancing with black balance. And to do that, we're going to take a look at each camera's black level by just simply closing the iris on each camera. So camera 1, we'll turn that all the way down. Camera 2, we'll do the same thing. And then camera 3, we'll do the same thing there. And what we're looking for, we're looking in the center of the vector scope as we go and look through each camera. And it needs to wind up right in the center, which is exactly where it is in all 3 cameras, which is very good. Occasionally you'll see it off to the side. And some cameras have fixed black balance. Other cameras have a automatic black balance adjustment that you would go through a sequence. You would just flip the switch and it would automatically black balance itself. But it's good on all 3 of these cameras. Now we can move on to white balancing. And to do that, I'm going to move to our first camera and open the iris. And I'm going to zoom that camera into our high-tech white card. And the thing about this white card is you want to make sure that the white card, in a perfect world, you have all 3 cameras lined up like we do, and you have the white card positioned so all 3 cameras can point to it in the exact lighting that you're going to be shooting in. It will do you no good to white balance to lighting that is not the studio lighting that you'll be using, or if you're doing a sporting event, you're outdoors and you have 1 camera pointed in the shade at a white card and 2 other cameras pointed in the sun at a white card. That's not going to help you at all. You need all 3 cameras pointing to the same type of white card in the same light that you will be using for those 3 cameras. So here we are on our first camera, and what we want to do next, now that we've got our iris open, we want to look at the waveform monitor and make sure that that white level is all the way to the top end of the scale without going over. We don't want to push it so hard that it's actually clipping in the camera, because there's circuitry in the camera to prevent the white level from going beyond a certain amount, and it'll just clip and it'll give you a false reading of white. So you want to make sure it's just below that level. And you can see in the monitor how it kind of goes blue as we bring it down and how it goes pure white as it comes all the way up. But we don't want that. We want to bring it down a little bit and start right there. Then we want to move to our red and blue adjustment. And the way we're balancing a camera is we are adjusting the red channel and the blue channel to match or in conjunction or in accordance with the green channel. So the green channel is fixed. We're just going to adjust the blue channel and the red channel to get white. So I'm going to start with the red channel, and what I'm looking at is our vector scope. And you can see that the trace in the vector scope is off in the cyan blue direction. We want to bring that to the exact center. So I'll start by turning the red adjustment, and it looks like it needs quite a bit of adjustment. Now I'm adjusting the blue and bring that down, and then just keep spinning these adjustments until we get that right in the center of the trace. Okay, now we're going to our next camera and switch back to iris mode and adjust that up. And again, zoom in, fill the frame of the card, and open the iris just below the top. There we go. Change to red and blue mode, and our trace this time is just slightly off. So just adjust that down. To the center. Okay, and now looking between, now I'm just going to switch between camera 1 and 2, back and forth, and it looks like camera 1 needs a little touch up. Switching back and forth between 1 and 2, and that looks pretty good. Okay. All right, now I'm going to go to the Canon camera. I'm going to open the iris up to get our white level to the top of the scale. I'm going to zoom the camera in to our white card, and then hit the auto white balance button. Now as I switch between the 3 cameras here, things are looking pretty good. But we notice the Canon camera still is just slightly off. It's off in the magenta blue area. Well, there's no adjustment on the camera to change that, but I can change that in the TriCaster. So I'll just open the configuration panel by right-click on the preview monitor for the camera 3, and down here I've got this adjustment, white balance, and it gives me red, green, and blue. We can see that we're off in the blue direction a little bit, and if I make that adjustment, it just makes it worse. So that means I need to adjust and push it in the red a little bit, not a whole lot, and then the green moves it over. Again, I'm just trying to hit the center of that trace. Just like that. Very slight adjustment, but you know, it's good to start with your best settings. So now when we switch between cameras 1, 2, and 3, we can see that that trace stays right in the center, and that tells me that all 3 cameras are balanced with each other. So now I'm going to go to our Canon camera. I'm going to open, or I'm going to zoom out a little bit so I can see the surrounding area. I'm going to go to camera 2, do the same thing. And we're going to go to camera 1 and zoom that out. And we're going to look at all 3 of these cameras. Camera 2 iris could come down just a little bit. And camera 2 up a little bit. And there's 1 and 2, and they look pretty matched. Camera 3 is our Canon camera, and we can see on our waveform monitor that our white levels are all the same, and our color is looking good between all 3 cameras. So there you have it. There's a very basic concepts in color matching cameras. We've matched 2 identical model and manufacturer types, and we've matched that with a 3rd camera that's a different model and different manufacturer. So again, with these adjustments, these are basic fundamental concepts in manually white balancing cameras, and I hope it makes your productions look that much better. Well, if you have any suggestions or techniques that you would like to see on this program, please feel free to leave comments in the comment section of this video. Until then, my name's Rex Olson. On behalf of everyone here at Newtek, thanks for joining us.